Introduction to Binomial Distribution. Okay, so in this video, I'm going to try to continue with that random variable concept, except this one is going to be with regards to the binomial distribution. Now, for probability distributions, I did an introduction. I'll put up a link up above there that you probably should watch before. Now, if you are familiar with probability distributions and you're just interested in now the binomial distribution, then you've landed in the right place. So I'll talk about a few things, and I'll do it through an example so that you can kind of understand all the different terminologies and then how it relates back. I think once you grasp the concept, it's not very difficult. But of course, if you are just coming into it, everything always seems difficult. So there's going to be a few assumptions, and I'll talk about them through the example where they should make a little bit more sense. Okay, so you're going to have a certain number of trials that you're going to be dealing with. Now, you're going to say, what the heck are these trials? So again, I'll talk about that through an example. We'll assume that they're all independent. Okay, so that is important, because if there is dependence, then of course probability changes. Now, there's only going to be two possible outcomes for each trial, either a success or a failure. And then the example that I'm going to do is going to be the simplest example possible. So it's not going to be very exciting, but I think it will serve the purpose to explaining this binomial distribution. So you can think of success and failure. Let's say, one single trial would be like flipping a coin. So, if you flip a coin and let's say you assume that for you, success is that you're going to see a heads. Okay, so that means if it was flipped and you saw a tails, then that would have been a failure. So there's really two possible outcomes there. So either heads, which would be a success, tails, which would be a failure. Okay, and I'll go on with that. And then there's not, heads and tails are not the only possible things. You can do all kinds of different other things, and I'll present you an example, a different example with, for example, viruses, and then what success and failure would mean there. Now, the probability, so some probability P, let's say, of success is the same in each trial. So if you're flipping the coin and it's a fair coin, so you'll know that it's independent. It doesn't matter how many times you flip it. The next one is always going to be, 50% heads, okay, in terms of success. The random variable that we're going to be trying to model within here is going to represent the number of successes in a given number of trials. So you can have as many trials as you like. You can have just one flip of a coin, so that would be one trial. And then you can say that your random variable is basically the number of successes that are possible in that one flip. You can have two trials, so two flips of a coin. And, so you would flip it once, and then you would flip it again, and then you can, jot down all the possibilities that you might have. And then your random variable would just simply say, okay, so, how many successes did you have? And that could be 0 successes, means that we've only seen tails. It can be 1 success, which means we've only seen heads once, okay, in the number of trials, okay? Or 2 successes, or 3 successes, and so on. So your random variable is going to take on the values of 0 success, 1 success, 2 successes, 3 successes, all the way up to the number of trials that you've actually completed. Now, as you know, let's say if you did it 5 times, it would be very difficult for you to get, or at least the probability would be low, to get all of those trials to be a success for you in terms of, let's say, seeing a heads multiple times. All right. Now, it turns out that the probability distribution can be modeled, okay, by this particular equation. And then, so I'll explain this to you as we're going through the examples. Okay, so the x itself there, as you see, okay, is going to be the number of successes in a trial. So I already said it could be 0 successes, 1 success, 2 successes, and so on. Okay, the n that you see there is going to be the number of trials that we're going to take on. So it can be maybe one trial, we're just doing one flip of a coin, or it could be 5, where we're doing the flipping of the coin 5 times. Okay, the P stands for the probability of success. So for us, flipping a coin, the probability of success is actually 50%, and the probability of failure is 50%. Okay, so let's take a look at this flipping of the coin, and then I hope that it will make a little bit more sense to you. Okay, and then what that binomial distribution. Now, the word binomial, so bi just means 2, is because we only have a success and a failure. Those are the only 2 possible outcomes for us. That's why it's actually called binomial. The distribution component goes back to the probability distribution. So in a binomial, exercise like flipping a coin, where you have a success or a failure, all you want to know is how many successes you've had. And then the distribution will be across all the possible trials. Okay, so let's see this. So if we had, for instance, just one trial, so we're just flipping a coin one time, right? So for this, the probability, would have been, we would have no success, at all, or we would have a probability of just having one success. So probability of no success just means that we have actually seen on our flip just the tails. And we know that this would have been at 50% or 0.5, right? And then seeing a successful, so meaning seeing a heads, the probability of that would have been also 0.5 because the coin is a fair coin and we see heads or tails at a 50% chance. So for this, our binomial distribution just with one trial, if we were trying to model this, so if I was going to do that, so let's say, we have, and I'm going to try to do that, and I'll put the 0 in here, so this is 0 successes and 1 success. This would have been our X, all right? So that's our random variable. So a random variable just means, all right, so if I have 0, that just means I didn't see a heads, right? So that wasn't a successful trial for me. And if I do see a heads, right? So if I can only see one, I've only done one trial, so it can be either no successes or one success. All right, so I would have seen that. And we know that the probability, so the probability of X, this is really just 50% or 0.5 for both of them. So we would have seen this is as our distribution, our binomial distribution. You can draw this out like that. So that's what we would have had. And in this case, it's it's a uniform distribution as well, because that's what we would see there with just one trial. But now you don't have to stop at one trial. Binomial distributions typically are related to multiple trials that you would have. So for instance, if I now go ahead and I would change this and I would say, what if I had 2 trials? What if I had 2 flips of a coin, right? So now all of a sudden the question is, okay, so you can either have, 0 heads in 2 trials, you can have 1 head, so you can have 1 success, or you can have 2 successes. And now you can map accordingly, what is the probability of, not seeing any heads at all? What's the probability of seeing 1 heads? And then what is the probability of seeing 2 heads? And now with only 2 trials, we can actually just really write this out, right? You can even do a tree, so a branching tree where you're just starting off, and then this would have been just 2 trials. So within here, so what would I have? Well, within 2 trials, I can possibly see, a tails and a tails. This would have really been represented by this. What is the probability of that? Well, the probability of seeing this would have been 1/2 multiplied by 1/2, which is just simply 1/4, right? Now, probability of seeing 1 heads, well, this can happen 2 different ways. It can happen when you see a tails and a heads, or it can happen if you see a heads or a tail, right? So now, for this, okay, because of the fact that I have a sea of tails and a heads, so that's a quarter, okay, possibility, but it's also a quarter possibility for seeing a heads and a tail. So this has a probability of seeing one success, one heads, okay, would have happened 1 over 4 plus 1 over 4, which is just 1/2, right? So that's what we would have seen right there. And then seeing 2 heads in total, so that's the same thing, okay, as this one. So this can only happen, so probability of this would have been 1 over 4, all right? And those would have been all your probabilities that we would have, okay? And those are the trials. So I had 2 trials, and within those 2 trials, I can have either 0 success, 1 success, and 2 success. And now the binomial distribution, so if I would kind of graph this out again, so now I have to increase this. So my random variable x is the number of successes that I had. So I either had 0 successes, I had 1 success, or I had 2 successes, right? So now the highest one here is 0.5 in terms of my probability. So this is px, okay? And let's say this right here would have been 0.25, which is just 1 over 4. So seeing 0 successes is basically, mapped up to here. Seeing 1 success would have been right here, okay? And then seeing 2 successes kind of is right there. So that is 2 trials, right? And this is now your binomial distribution that you would have. So you can see that if you sum up the entire thing, so if I sum this up, this plus this plus this, really this summation is going to equal to 1. And that shouldn't surprise you, because if you sum up all the probabilities, they should sum up to 1. Right? So now this binomial distribution with 2 trials, so this was with 2 trials. Now this one right here was just with simply 1 trial. So that's what I had right there. And now you can continue this on, right? You can now take 3 trials, you can take 4 trials, 5 trials, or as many trials as you like, right? Now, the probability of success, so here is what I want to show you, right? So the probability of success is summed up in this particular equation, all right? So let me copy this, and I just want to show you how this works, okay, within here. So sure, we can certainly do it individually, right? Where we are doing something like this, and we're finding out all the possibilities and so on. But, for instance, if I take the probability of 1 success, right? So we know that this comes in 2 different ways. Either you get a tails and a heads, or you have a heads and a tail, right? Within here. So those are 2 possible trials that you would have. But within here, you can use your combinations, so you're counting. So instead of actually writing them out, now it's simple to do it when there's only 2 trials. But if you have 5 trials or 10 trials or 20 trials, you don't want to be writing all of these things out. They're going to take forever. So how do we do that? Well, we know right here that, we had 2 of these successes within here. But that's like saying, well, I have 2 trials and I'm going to choose only 1 success. And 2 choose 1 is simply equal to 2. Okay, and now if you want to know what the probability is, well, the probability of success is 0.5, right? And then the probability of failure is also 0.5. So if you really wanted to know and get this 1/2, you can use it in exactly the same way. So notice, probability of having 1 success. So this is 2 choose 1. So that's coming from here. But now if you want the probability, you're going to have to multiply it by the probability of success. Well, it only happened 1 time. And then the probability of failure, which is 1 minus p, which is also 0.5. Now this was 2 minus 1, which is 1, which should make sense to you, right? You had a tails and a heads, right? And then how many combinations of those did you have? You had 2 choose 1. You had 2 of them. So if we do this, this is going to be 2 multiplied by, so 0.5 times 0.5, is 0.25. And this is just equal to 0.5 or 1 over 2, as we saw right here. So this equation right here, now you don't have to necessarily memorize this. If you're comfortable with combinations and knowing how to count the possibilities, then it shouldn't be really a big deal to you to try to find this out, right? So now as a starting point, typically students will try to memorize this and then they'll just use it. But I hope that you can see, okay, the power of this. So let's imagine that, we wanted to have, instead of, 1 or 2 trials, let's say that we wanted to have, maybe 6 trials. So we wanted to have 6 trials. And now the question might be, you can certainly do what is the binomial distribution. So the binomial distribution would have been, now our x, okay, is either we have, no heads at all. We could possibly have 1 head, 2 heads, 3 heads, 4 heads, 5 heads, or 6 heads, right? Within 6 trials. Those are all the possibilities. And now we can map these to the appropriate, probabilities and find out what the binomial distribution is. And I'm going to just show you that on decimals to map it out, okay? So that you can, instead of just, doing this right here, where you're doing it by hand, which is great because it gives you some intuition, you can also map it using some kind of a digital tool. So a question that I can pose for you here is, now that you have 6 trials, let's imagine that, you wanted to know 2 successes. So in our case, we said success was flipping and then seeing in actual heads. So what would have been the probability of that? So instead of listing all of these out, you have 6, 1, 2, 3, 4, 5, 6. So there's 6 trials. And now you want to know only 2 successes, okay, within here. So for 6 of these, the way that I would find this out, the probability of seeing 2 successes in here would have been, okay, so I have 6 choose 2, because those are all the possible ways that I can arrange the heads within, right? But now, because I want to know the probability, well, the probability of just seeing it 1 time, well, what's the probability? Well, the probability is, okay, 0.5 of seeing a heads. Now, I've only seen it 2 times. Now, the rest of the other values would have been the tails, which are the failures. But the failure is 1 minus the p, 1 minus 0.5, which is also 0.5. Okay? And then how many of those did I see? I saw 4 of them. And that, again, is basically just this equation right here. So notice n choose x, p to the x, so x is the number of successes we had, multiplied by 1 minus the p, which is the failures, to n, which in our case is 6 minus the 2 of x, which is 4. And that shouldn't surprise you, right? Because, you could have, for instance, a heads, a tails, and a heads, tails, and a tails. This is, okay, seeing 2 successes within here. But those heads don't have to be in the 1st and the 4th position. They can be in many different other positions. But this counting takes care of all of those possibilities for us, right? So we have 6 choose 2 possibilities within there. And so within here, okay, this now is the remaining amounts, okay, in terms of the probabilities. So you can do that for every single thing. You can do it for the probability of seeing no successes at all. Now, this one would have been actually kind of simple because that means all of them are tails, right? You can do that for probability of seeing 1. You can do that, as we did here, probability of seeing 2, okay, or 3, or 4, or 5, or 6, okay, etc., right? So now what I want to do is I want to just show you how you can map this out onto decimals if you want to see the nice probability distribution, okay, scaled out for us. So I will have to bring out decimals, okay, so I'm going to bring this out, okay, within here. So now, we're kind of right there. Okay, so to map this out, it's like mapping out, a discrete function, because now we are dealing with a discrete, condition in terms of mapping this. So to map that out, so this is going to be, so I'm going to put n is equal to, this is 1 dot dot dot, comma, capital N, where this n, for us is going to be 6 trials. So this just gives me, 1, 2, 3, 4, 5, 6. Actually, I'm sorry. We have to start from 0 because we have 0 successes, within here. So that's what we would have there. So that capital N is the number of trials, right? That's what we would have within. Now, my probability function, so I'm going to put it as a regular function. I'm going to just say f of x, is equal to, and now I'm going to put n choose x, and I'm going to pop up, let me maybe make this a little bit bigger. I'm going to pop up functions right here, and Desmos actually has n choose 2. So let me just kind of go back in here. There we go. So n choose 2. This is going to be, so n, and we are choosing x, all right? Well, don't worry, on the right hand side we'll get rid of all of those things that you see there, in green popping up. This is going to be multiplied by the probability p, and that probability p, so we're going to put, for us is 0.5 times, 1 minus the p, and I'm sorry here, so we're going to have to raise this up to the x. And this is going to be raised to n minus, it doesn't let me do it, so I have to put it in brackets, n minus x. So that is my actual probability for each individual point. And now to map it, we're going to put all the ordered pairs, so n, and we're going to substitute that, into in here, all right? And I'm going to remove, this one just so that we can see the distribution. So you notice that it's a nice, beautiful distribution within here, within that. And now, probability of seeing 2 successes, so notice within here, so it was 0.2344. So if I go back in here and I try to compute this, so let me maybe move this out. And let's try to see. So that was 6 choose 2, multiplied by 0.5 squared, multiplied by 0.5 to the 4. So this right here, together is just 0.5 to the 6, and then 6 choose 2, which we can do. So this is 6 factorial all over 4 factorial multiplied by 2 factorial, right? So that's going to be 6 times 5, because the 4 factorial cancels out, and then the 2 right here, so that's going to be just 3, so this is 15. So my answer, if I pop up my calculator on the right, so 3 multiplied by 5, and then multiplied by 0.5 to the 6 equals. And there you have it. And notice what did Desmos have for, let's see if I push this over. This was right here, 0.2344. So Desmos just rounded that up. And that is my distribution. So what you can see there is, what's the probability of no successes, meaning just seeing all tails. What is the probability, of seeing 1 heads, right? And that can happen in 6 different places. What's the probability of seeing 2 heads? What's the probability of seeing 3 heads within here? And then what's the probability of seeing 4 heads, 5 heads, and 6 heads? So you have this nice kind of distribution that goes along, that way. And you can do this for any. So the beauty here is, if I remove this, let's say, and you wanted to, I'm going to go back in here and let's say for n, what if you wanted to do this, with 10, right? So notice that there you go, there's your distribution for 10. But what about if you wanted to do it for 100, right? So for 100 successes, now maybe I should be careful here. There we go. Look how nice this looks like. Okay. So that's the number of successes, and this becomes your distribution. So the bigger the n, the number of trials, you can really see what is happening with that distribution. And for your probabilities, okay, that we have in here, this works for all your binomial distributions. So the probability doesn't have to be 0.5. It can be anything that you like. And you can put it in there, and then you can actually watch the distribution. And in decimals, this is super neat, because once you do this once, it will actually map it out and you can see that distribution. Imagine trying to graph this on your own with 101 points. That would have been a pain in the butt. And then calculating, those probabilities would have been rather hard. So that's what the binomial distribution is, right? So now just so that you can see, what if I switch this and I made this 0.2, that the success rate, so let's say if it wasn't flipping a coin, maybe it was some kind of a sports competition, okay, and the success of winning was only 20%. So in the number of trials, okay, what would we see? And notice that it shifts this out quite a bit, right? Notice that the highest peak happens actually at 20, okay, because we actually took about 101 elements. Okay, and notice it still has that peak, but it's no longer centered, right? And so this you can arrange anywhere you like. What if I made it 1? Okay, so you would see that it just gets shifted to this. Now, what if the probability was much higher? Well, you'll notice that the number, okay, is going to be centered around a little bit further out, because, okay, we are expecting to have much more success, okay, and many more successes if the probability is higher, right? If we do this and let's say we get to 90%, notice that not getting many successes in the beginning, it's a low probability, and then as you're getting further out, it's very high probability, and then it just kind of drops out. Now when I say high, it doesn't mean that it's 100%, but it's the highest peak, right? And this is how it distributes across, okay, all the different levels. The last thing that I wanted to be able to talk about within here, okay, I'm going to try to add another page, is the expected value. So you saw that in probability distributions, you can calculate what the average, okay, what would have been the average or the expected value. Now, for the binomial distribution, you have a very nice equation that this actually just equals n, which is number of trials, multiplied by the probability of success. That is your expected value. Now, you might say, how did you know that? Okay, well, because it's only dealing with probability of success and probability of failure, right? And then you have n number of trials. So you can take n and then multiply it by that p. But if you want to see how this is derived, because again, please remember that the expected value is, right? So this would have been for, first it's, 0 successes multiplied by, the probability of seeing 0 success plus 1 multiplied by probability of seeing 1 success plus, so on, all the way n times the probability of seeing n successes, right? And we have to add all of this up. How does this equal to n times p? I did a proof of that if you really are interested, but if you're not, you can use the formula and find out what the expected value, what the average would be, right? But for the proof, okay, I'll put the proof up above there, okay, a link for you so that you can do it on your own, all right? Okay, so that's pretty much it for this video. I think it's long enough, but I do hope that it gives you some gist of understanding binomial distribution. Okay, I'll do one more example, but I'll add that up to a different video, which is going to be this example, so that you can see it, and then I'll keep the decimals as well, and then everybody is going to be able to kind of walk themselves through this. All right, so thanks for watching this. Okay, so this video was with regards to binomial distribution. So now I hope you understand, what the trials are. You understand what success and the failure might be. Okay, the probabilities, and then that the random variable is just simply the number of successes that we have in a given number of trials. Thanks for watching. Okay, hopefully we'll see you in that example. Bye, everybody.